Stoichiometry of Growth and Product Formation, Part 2. We'll be doing it online. The reason is that because it has a few equations and calculations that I need to teach you guys, and because your number is quite big in the class, so I feel it face to face, it will be very hard for me and also for you as well. So I think that this will be the best medium, okay, now for this topic. All right, so I'll be using this kind of notes. Okay, is it clear for you, the screen? Okay, so in case if you find any issues in my screen or my voice, do let me know, okay? So last class we studied about stoichiometry, what is its definition and so on and so. Okay, so today we are going to see few equations that can be applied for this stoichiometry with regard to the microbial product or microbial cells. Okay, so over here, when we talk, it's given that when we talk about the cell growth or product formation, we can always use the law of mass. So I did explain this to you in the last session, okay, if you remember, right? Okay, now, next we are moving on to the general equation for aerobic growth, aerobic cell growth. Okay, so from today session, from this session for today, we'll focus more on the stoichiometry with respect to the microbial cell growth. All right. So in order for the microbes to grow, we need to provide a carbon source. Okay. And then we need to give them oxygen, and then nitrogen source is also needed. And then when they grow, we get the biomass, and then carbon dioxide and water goes as the end product. So I want everyone to just take all these notes that what I'm going to teach you today, because I won't be giving you any other extra notes for this, okay? So there will be some kind of calculations and equations and everything. So make sure that you take all these down, okay? All right. So I mentioned that we need to give a carbon source, okay, then oxygen and then nitrogen. So we get the biomass, carbon dioxide and water. Now, this same thing we are going to define in terms of elemental composition, which is carbon, hydrogen, oxygen and nitrogen. So we are going to rewrite the above equation. Here we have carbon, hydrogen, oxygen, nitrogen. Okay, plus we're giving oxygen plus nitrogen, oxygen, and nitrogen. So this will give rise to some product, isn't it? So it will be carbon, hydrogen, oxygen, nitrogen. Oh, sorry. Plus, always there will be carbon dioxide formation and also water. Okay, so here we give this as W, X, Y, Z, and then we give this one G, H, I. This one we give alpha, beta, S, and yeah. So for here we give N, A, B. Okay, this goes as small letter C, D, and E. So over here you can see that all these letters like W, X, Y, Z, and G, H, I, alpha, beta, so and so. These refer to the number of atoms. Okay. Now, the next thing, what you can see is these ones. Like you can see over here is N, A, B, C, isn't it? So all those things we call A, B, C, D, E, all will go as stoichiometric coefficients. Okay, coefficients. Okay, so everything okay so far? All of you can follow? All right, thank you.
Yes, doctor.
Now, next what we're going to do is I want you to write down, so you have to write this, okay? Write down balance equation. Balance equation for oxygen, nitrogen, hydrogen, and carbon. From this previous equation, which is this one, okay? I have to write it quite a bit big. That's why it doesn't look that neat, okay? Because of the iPad I use, okay? I can only go this much. So you have to write down the balance. Now, let's try for nitrogen first, okay? Nitrogen balance equation. Now, for nitrogen, when you see over here, here you have 1, isn't it? So it goes as NZ, okay? And then you have over here, which is I. So it will be BI. So equals to, over here is S and C. It will be C and S. So you're going to write down the nitrogen balance like this. NZ plus BI equals CS. Okay. Now I want you to write down for hydrogen as well as oxygen. Okay, so I want you to try by yourself, first hydrogen and then oxygen. So you have to see for hydrogen. You can see over here. Okay. So this is called the balance equations. So did you get this one? What I wrote it down now for hydrogen as well as oxygen? From this
Doctor.
equation.
Doctor.
Yeah. Yeah, yeah.
Yang di can scroll down, was elektron gitu dokter. Yang
Sorry?
I itu. Yang oxygen balance to electron, E 2E. Oh bukan I
Oxygen.
yang okay.
No, no,
I
these
from
are
apa
just
nih?
just the
Okay.
stoichiometric coefficients like E. This
Okay.
one, right? You're talking about this one, Ken?
Yes. Yeah, yes.
Yeah, no. Just this is just the stoichiometric coefficient.
Oh, okay. Okay, doctor. Sorry.
Okay, no problem, no problem. If it's not clear, you can ask me, okay? So how about others? Did you get these balance equations for oxygen, hydrogen, and nitrogen based on this? This one maybe I can term it as equation number 1. Okay, you have to find out the number of carbon or hydrogen here. Here is for oxygen is Ny, you can see N, okay, Ny plus here you have 2A. You can see A and 2. So it goes as 2A plus here it goes as B and H. See, this is H, isn't it? So it comes as BH. No, so yeah, BH. And then equals to, you have to find on the right hand side. Okay, so that one will go as the oxygen balance, and similarly the same thing for hydrogen. Is it clear, all of you?
Yes.
Okay, all right, thank you. Now we're going moving on to the second part of today's lecture. Okay, so we are going to the cell biomass. So the cells are normally made up of carbon, hydrogen, oxygen, and nitrogen, isn't it? So hydrogen is 1.8, okay, and then oxygen is 0.5, and nitrogen is 0.2. Okay, now this can be used as a general formula. Okay, general formula for cell biomass. Cell biomass when the composition is not given. Okay? Because sometimes in the equation they will give you the composition of the cell biomass composition. Now, when it's given, you have to use that one. But if it is not given, you have to use this formula, which is CH 1.8, 0.5, O 0.5, and N 0.2. Now, I want everyone to calculate the molecular weight of this biomass CH 1.8, 0.0, 0.5, and N 0.2. Can you calculate the weight? Okay, I'll give you the molecular weight of each one. Carbon is 12. Okay, hydrogen is 1. Oxygen is 16. And then we have is nitrogen. Nitrogen is 14. So use this one, and then you have to find the molecular weight of this biomass. If anyone get the answer, please let me know. Did you understand my question, all of you?
Dokter, jadi
Yeah.
kira molecular weight untuk formula ni, dokter?
Yes, this is the molecular weight for each one. So you have to substitute this in this. You got it?
Okay, dokter.
So what you got the weight, dry weight of the cell? Did anyone get it? Did anyone get the answer? So substitute. Okay, this was the dry weight, isn't it? 1.8 or 0.5 and N 0.2. Now we have carbon to be 12. So we have one atom, one molecule, isn't it? So 1 times 12 plus hydrogen is, we have 1.8 here, okay? So 1.8 times hydrogen is the molecular weight is 1, right? Plus oxygen is 0.5 here times the molecular weight of oxygen is 16. Okay, plus oxygen is 0.2 times the molecular weight of oxygen is 14 equals, how much did you get when you add all these? Yeah, correct, 24.6. Okay, so this is the dry cell weight. Why I call dry cell weight is we don't take the water here, okay? Weight of water is neglected. So this is how you calculate the dry cell weight. Now, next we are moving on to a different part, which is called the respiratory quotient. Respiratory quotient. Okay, we denote it as RQ. So this equals moles of carbon dioxide produced by the microorganisms over moles of oxygen consumed by the microbes. Okay. Now, for RQ, if you go back to this equation, okay, if you go back to this equation, we have to see the moles of carbon dioxide produced, isn't it? So here is D moles over the moles of oxygen consumed, which is A. So we can denote this equation as D over A. Clear, all of you? Okay, now we're going to do some calculation. I will forward the question to Noor Aina in the WhatsApp. Okay, so she will share with you guys. Aina, are you there? Aina. Okay, so all of you got the question? Please read it first, okay? Okay, so I want every one of you to first pay attention. Okay, I read the question. The elemental composition of dry biomass of a yeast species. So this is the yeast species. The elemental composition is given here. So this is it. Okay, you can see it in the screen. We have carbon, hydrogen, oxygen, nitrogen, sulfur, and also phosphorus. Now, the contribution of carbon to the dry biomass, you need to find out what is the contribution of the carbon to this dry biomass, but it should be in percentage. Okay. And the instruction is given, you need to round off to the 2 decimal places. Now, you have all the atomic weights of hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur is given here. So you need to find out. So for this, first what you need to do is you need to calculate the molecular weight of this molecular weight. Okay, so first calculate the molecular weight of this yeast species. Now, how you're going to do is use this what you call the formula given here. Okay, so I will just show you how to do. So the first one is carbon. Carbon is 1, isn't it? 1 times the molecular weight given is in the question is 12. Okay, plus hydrogen is 1.6 times the molecular weight given is 1. Okay, so can you please do accordingly? And I want to see what is the molecular weight. So the same process goes for all. For oxygen, then you go for add, and then you go for nitrogen. Nitrogen is 0.2 times the molecular weight given is 14. Okay, and plus. So I want to see, and then finally you get an answer. So let me know what answer you get. Anyone got the answer?
18.5824.
18?
Bukan.
No, maybe you went somewhere wrong. Yeah, correct. 23.404. Andrea, yeah, Andrea is correct. Okay, so if you go this way, then we have 0.2. Then we have sulfur is 0.0024 times the molecular weight of sulfur given in the given as 32, right? Okay, plus, and then we have phosphor here 0.017 times the molecular weight given is 31. So all this, when you calculate, you should get 23.404. Now, this is not the final answer, okay? This is only the molecular weight of the yeast species here. You got it, all of you? Now, from this, what you have to find is, you have to find out only the percentage of the carbon. Now, percentage of carbon is, its atomic weight is 12, isn't it? So we just put 12 over, this is the total molecular weight, which is 23.404. And since we need the answer, since we need the answer in percentage, we need to multiply by 100. So when you do this, how much do you get? How much did you get? 51.27. Yeah, correct. Okay. So this will be your final answer. Okay. Is it clear? Any doubts here? You can expect similar questions for your midterm, okay? It's quite simple. If you just understand the concept, you can do. Yeah. Noor, Aina said 51.27. Yasmin, 51.27. Andrea, 51.27. Yes, correct. Good, good. All of you. I'm happy that you can follow. And Noreen a bit, but okay, still can accept. She said 51.28. Okay. All right. So that's how you calculate the contribution of carbon to the dry biomass. Okay. Okay, now I'm going to give you our next question. So I'm going to forward it to Aina again. Okay, so this one is about the empirical formula. So I want you to read that first. Then we discuss as how to move forward with this question. Okay, so I read the question first. The empirical formula for biomass of an unknown organism is given CH 1.8, O 0.5, and nitrogen is 0.2. Okay, that's an unknown organism. Now, to grow this organism, ethanol, which is C2H5OH, and ammonia are used as carbon and nitrogen sources respectively. Now, you just assume no product formation other than biomass, because sometimes in the microbial, when the microbe comes, we get the product as well, right? But over here, it's clearly given that assume that no product formation other than the microbial cells or the biomass. Now, to produce 1 mole of biomass from 1 mole of ethanol, the number of moles of oxygen required will be. Okay, so first we need to form an empirical formula, because only the empirical formula, no, empirical equation, because only the empirical formula is given. But they mentioned that to produce 1 mole of biomass from 1 mole of ethanol. Okay, so let's form the equation first. C2H5OH is ethanol. So ethanol, and then there is number of moles of oxygen, isn't it? It needs to combine with certain amount of oxygen. And then here it's mentioned that ammonia is used as the nitrogen source. So we have to write ammonia, which is NH3. Okay. Then the end products are biomass, but the biomass is already given in the equation. You can see as C H, okay, O, N. Now in the question, it's given as H is 1.8, isn't it? Oxygen is 0.5, and here we have 0.2. Now, always whenever there is a reaction, they say only the biomass is produced. Even then, there will be carbon dioxide and water as the end products. Okay. So far clear how we design this equation, all of you? Any doubts? Because it's given that to grow this organism, ethanol and ammonia are used. So this is the ethanol, okay? and then this is the ammonia, and then oxygen. Okay, can we proceed to the next step? Now, in the question, they say that 1 mole of biomass is produced from 1 mole of ethanol. So you can write ethanol is 1 and the biomass is 1. So 1 mole and 1 mole, because it's already given in the question. Now we are not sure how many moles of oxygen, so we just put as A, and we don't know about how many moles of ammonia, we just put as B, and we are not sure about the same thing goes for number of moles of carbon dioxide, we put as D, and for water we put as E. Okay, so this will be our final equation. How we're going to find out the number of moles of oxygen. The question is oxygen. Okay, we need to find out this one. This will be your final answer. Now, in order for you to find out oxygen, what we need to do is, first we need to find the balance of carbon. Okay, find carbon balance. All right, so here you can see carbon is 2 here. Okay, yeah, is 2. On the left hand side you don't have any more carbon, and then on the right hand side you have here 1, isn't it? And here 1. So this will be here D. So you will have 1 plus D. Now from this you can find out D. So D will be equal to 2 minus 1, which is 1. So the answer is D equals 1. Okay, for you've already found the carbon balance. Okay, now your next step is you need to find the nitrogen balance. Okay, you need to find nitrogen balance. Now nitrogen you can see is over here we have is B, isn't it? So nitrogen B equals, and on the right hand side you can find is 0.2. So B equals 0.2, and that is the value of B. Now your next step is you need to find the hydrogen balance. Okay, so can you find the hydrogen balance in this equation? The same method that we have done for nitrogen and carbon. Okay, anyone got the answer for hydrogen? Okay, so let's get how we're going to do the hydrogen. Now you can see for hydrogen here, okay, this one, if you see this part ethanol, you can see here 5 and then here 1, isn't it? So this goes as 6. Later. Okay, now let's find out hydrogen. Okay, okay, now hydrogen balance. So here we have, I told you, is 6. All right, plus hydrogen over here you have 3 and B. So it goes as 3B equals, on the right hand side you have here 1.8, and then here hydrogen you have is 2E plus 2E. Now from this, can you find out the value of E? Okay, someone told, yeah, Arman said the correct answer, E equals 2.4. All right, well done. And Siti Noor Faika got it 1.9. Good try, but there was some error. Okay, maybe your equation went wrong. Okay, so over here is 2E, and we just have the value of B, isn't it? From the previous one, we got B to be 0.2, and then substitute that value of B here. So you get 6 plus 3 times 0.2 equals 1.8 plus 2E. So you have to find this E, okay? So this will become 6 plus 6 point, sorry, 6 plus 0.6 0.6 equals 1.8 plus 2E. Now, you can get 6.6 here minus 1.8. You bring this to this side, okay? You will get 2E. Now, 2E equals, you have to calculate, it goes over here, and then finally you will get E to be, the value is, when you calculate, is 2.4. Okay, clear all of you? Any doubts so far? Because these are the important kinds of calculations in the stoichiometry. It's quite easy, but you need to pay too much attention to it, okay? Otherwise, it can go wrong. It's like 100% attention, and then you just put like 5% of your effort. You can find, because the molecular weight and everything is given, and you have to read the question 2 times. Okay, so you got E to be 2.4. Okay, now we got the value of B, D, and E. Now in the question it says is you have to find the number of moles of oxygen. Okay, so now what you have to do is find the oxygen balance the same way and substitute these A, B, and E into it, and then you will get the answer. Okay, find oxygen balance. Okay, so anyone got the answer? What's the value of the final one, which is final oxygen balance? Okay, answers. Now we have to find the oxygen balance. Any answers here in the chat box? Okay, I see Noor Mizatul Akma Chitli 1.95, Feeling 1.95. Yeah, that's a correct answer. Andrea, well done everyone. So Noor Mizatul Akma 1.95, Nana Shafina 1.9, Noor Faika. Okay, that's good. Okay, so I'm so happy that at least you guys can follow. Now, for those who couldn't follow, I'm just going to explain how we got. So please pay attention. Now we are going to find the final oxygen balance because that's what's given in the question. Okay. Now, for oxygen over here, you can find 1, isn't it? 1 plus, sorry, here is 2A equals, here is 0.5 because this is 1. We just 1 times 0.5 is 0.5. Plus over here you get 2D. Okay, 2D plus over here the oxygen is E. E. Okay, now we have certain values. So 1.2A equals 0.5 plus you put the value of D here. So it is 2 times 1 plus E. Okay, now this comes again as 1 plus 2A equals, you will get as 4.9 because we do have the value of E also, right? Okay, the E value is 2.4. So when you calculate, you get 4.9. Now, just a bit going up is 2A equals 4.9. This one, you bring it over here. It is 4.9 minus 1. That will be 3.9. So 2E equals 3.9 and A equals 3.9 over 2, which is 1.95. So this will be your final answer. Okay, so this 2 goes down. It's 1.95. So we learned about two types of calculations, okay, how to do and how you're going to calculate if they ask you the oxygen balance or the percentage of carbon from the biomass. Now we're moving to things, okay, before we wind up this session. We need to learn about the biomass yield. Okay, now we are coming to the next one, which is called biomass yield. Okay, now the biomass yield is the linear relationship between the amount of biomass produced and the amount of the substrate consumed. Now, if you remember my first lecture, I did say about the biomass yield, we can denote it as or calculate it as Y and X over S. This is X, okay? X over S. Now, this is equal to grams of cells produced, okay, over grams of substrate consumed. Okay, this we take as equation number 1. Now, the biomass yield, okay, can also be calculated in a different way using this equation. It also is denoted by Y, X over S, okay, and then it gives molecular weight. MW is molecular weight, okay, molecular weight of cells over molecular weight of substrates. So this goes as equation number Okay, so let's calculate this one biomass yield with a few simple questions. Okay, so now question number one. You are given, you need to write it down, okay, because I'm not going to give you the question as such in the written format, but I'll be explaining to you, so you can just write it down. So you're given 10 grams of glucose, okay, and from this around 12 grams of biomass is produced. Biomass is produced. Now calculate the biomass yield. Calculate biomass yield, which is y x over s. So please calculate based on these equations that I give you, equation number 1 and also equation number 2. Okay. Calculate y x over s equals 12 gram of biomass is produced and then 10 gram of glucose is utilized. Any answers? What is the biomass yield? Okay, how much of biomass the cells is being produced is 12, isn't it? So this one is gram cells produced. Okay, so gram cells produced is 12 over how much of the substrate is consumed. The substrate over here is glucose. So 12 over 10. How much is 12 over 10?
1.2.
Yes, correct. So 1.2, and the unit of biomass yield is always gram per gram. Okay, or you can also say gram per gram. Okay, so this is the answer. 1 point. Okay, now for this next question, which is question number 2 related to this one. Okay, so we have 3 molecules of glucose plus oxygen, and then it produces approximately, we say that 15 cells. Actually, it's hard to count the cells, but it is a hypothetical question. Okay, 15 cells plus the end products, carbon dioxide and water. Now, my question is find y x over. Okay, before that, one thing I missed over here is molecular weight of cells, isn't it? This part. Just hold on. This you can denote as C over N. Okay. So this goes for the molecular, C goes for the molecular weight of the cells, okay, here, and N goes for the molecular weight of substance. So you have to put this equation, which is equation number 2, for this question. Okay, equals to C over N. So the C over here denotes the molecular weight of cells. Now earlier I told you, because molecular weight of the cells is not given, isn't it? If no weight is given, you have to take this one, 24.6 as the weight of the cells. Okay, so this is the dry cell weight. If nothing is given in your question, you have to take 24.6. So now over here, we have 15 cells, isn't it? So equals to 15 times 24.6 over, we have How many molecules of the substrate? 3, that is glucose. 3 times the molecular weight of glucose is 180. Okay, so how much did you get this one? Any answers? Yeah, correct. 0.683. The units is gram per gram. Okay, 0.683. Who's that? Risha. Okay, Rishalini. Yeah, correct. Good. And Siti Nurfaika also good. Correct. 0.683. So the answer is always gram per gram. Clear, all of you? Any doubts so far? It's a new thing for you, I think so. So you need to revise, okay? So it depends on how you can revise, then it will be easy for you. Okay, now we have one more last topic for today, which is called product stoichiometry. Because all this while we were learning about the biomass, isn't it? Biomass yield, you can see over here is molecular weight, respiratory quotient, and so and so. So now we have a few things that you need to study about the product stoichiometry. Okay, product stoichiometry. Stoichiometry. Okay, so I want you to write down this equation first, then I explain. Okay, so over here you see an equation. It's a bit confusing, but this is written in terms of carbon, hydrogen, oxygen, and nitrogen. The reason is because it's easy to represent. Okay, and all these are the number of atoms like WX, YZ, GHI, alpha, beta, delta, epsilon, and JKLM, all those things. Okay, So over here you can see is N, A, B, C, D, E, and F. Those are the stoichiometric coefficients. Now our concern is this one, which is called the product stoichiometry. This is this product formed, and here this F represents the stoichiometric coefficient of the product formed. Now we are going to see how we can calculate the product yield. Okay, just now we learned about how to calculate the biomass yield, isn't it? So we need to see how much a product is produced per substrate consumed. So here we have what is called Y P over S equals gram product produced. Okay, product produced over gram substrate consumed. So this is the product. Clear? So far so good. Can you follow? Now I can use to calculate the product yield. Okay. So 25 grams of glucose reduce approximately 15 grams of ethanol. Please calculate the product yield or yield of product, which is Y P over S. Okay, and this is always 3 gram per gram. So what's the answer? Which is 15 grams ethanol. Okay, over the substrate 25 grams of glucose. How much you can get? 0.6. Okay, 0 Noika, Luisa, yeah, correct. 0.6. Okay, so 0.6 gram per gram. Right? So one more question for this. The next question is, we have this equation plus glucose plus oxygen give 2 So we have here glucose and oxygen give 2 moles of ethanol and 2 moles of carbon dioxide. So you have to calculate the product yield. Okay. So the molecular weight is given as 46 and also 180. Okay, let me see how much you get. Answers? Here the product is we ignore carbon dioxide, okay? So we have to calculate the product, which is ethanol. So we have 2 moles of ethanol and times the molecular weight is 46. And the consumed is we are ignoring oxygen. We only go for the glucose. So the glucose molecular weight 1 mole times 180. So how much did you get? Yeah, correct. The has been correct, 0.51. Okay, so the Noor Faika 0.5, Noor Faiza 0.5, Muhammad Iqbal 0.5. Yes, we are not of you. Okay, I'm so happy at least you guys can follow. Okay, Alhamdulillah. So this is 0.51. Okay, so that's it regarding this documentary. Okay. We have covered for part 1 and also part 2. Part 1 is basically more towards the theories and all that. So part 2 is a bit about how you calculate all these things. Okay. Before we end today's session, I want to share the attendance for today. Okay. Just hold on.